Welcome back everyone. So in this session we are going to understand the common roots of quadratic equations. Now there could be one or more common roots for the pair of quadratic equations. Let's understand how. Let's understand in graphical representation. That would be much more clearer for you. So let's say this is x and y axis, and let's say if it is a quadratic equation with positive a, then these two roots are there. Now what if there is a quadratic equation comes whose roots somewhat nearer to this original equation? So let's say there is this equation whose roots are like this, 1 and 2. So as you can see, there is this equation, there is this particular value where both the equations are coinciding, or I can say this is a common root of this quadratic equation, right? Let's see one more scenario. This is x, this is x and this is y. Now let's say there is this quadratic equation whose roots are these 2 points, and now another quadratic equation comes something like this, and where both of the roots are common. So any of the case can occur. See, let's say this is quadratic equation 1, this is quadratic equation 2, this is quadratic equation 3, and this is quadratic equation 4, right? So both of the cases can occur. That is, if I talk about common roots of quadratic equation, then mainly two types of cases can occur. First root will be both the roots are common. Let's say we have two equations as a1 x square plus b1 x plus c is equals to 0 and a2 x square plus b2 x plus c2 is equals to 0. These are our two equations. Now let's say the two roots are alpha and beta are the roots. What am I trying to say over here is, if both the roots are common, then in that case product of both roots should be same for both the equations. That is alpha into beta, or I can say C1 upon A1 for equation 1 and C2 upon A2 for equation 2, these two should be equal. And if these two should be equal, then A1 upon A2 should be equals to C1 upon C2, right? Now proceeding towards our second point, that is, if both the roots are same, then summation of roots should be same. That is, alpha plus beta is equals to minus b1 upon a1. This would be for first equation, and minus b2 upon a2, this would be for second equation. These two should be same, and if these two should be same, what I can imply from here, that is a1 upon a2 should be equals to b1 upon b2. This result came from second. So if I compare my first and second value, this is my first, this is my second value. If I compare these two value, what I am achieving from here, that if both the roots are common, then a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. this is one condition that I have achieved. I hope it is clear to you. So what you need to do, if let's say in particular question you are asked check whether these two equations will have common roots or not, all you need to do is just check whether these two equations are satisfying this condition or not. If they are satisfying, yes, they have both the roots common. If no, then no. Let's proceed to our next condition. Now proceeding towards our second condition, that is, what if only one root is common? So that is what we are going to solve now. What if only one roots of common between these two equations, and let's say the roots of this equation is alpha and beta and roots of this equation is alpha and gamma. So as you can see, alpha is the common root. Alpha is the common root over here, right? Now, if alpha is the common root, then by putting alpha, what I am going to achieve is a1 alpha square plus b1 alpha plus c1 is equals to 0, and a2 alpha square plus b1 alpha plus c1 is equals to 0, right? And if I solve these two equations using crisscross method, so what I will be achieving is, just try to recall what we did in pair of linear equations. Alpha square upon, firstly this will be b2 and this will be c2, right? So firstly b1 c2 minus b2 c1 is equals to alpha, then this will be what? a1 c2 minus a2 c1, and lastly 1 upon a1 b2 minus a2 b1, right? Now if I try to solve this, let's take first two terms common first of all. So what I'll be achieving is alpha is equals to b1 c2 minus b2 c1 upon a1 c2 minus a2 c1, and taking the last two term also I'll be getting alpha only. If I take this over here, so I'll be getting a1 c2 minus a2 c1 upon a1 b2 minus a2 b1. So I have achieved the necessary condition if one of the roots is common, and that is b1 c2 minus b2 c1 upon a1 c2 minus a2 c1 should be equals to a1, see this denominator will be same, a2 c1 upon a1 b2 minus a2 b1, right? So this will be the necessary condition for if one of the roots should be common. So that was all about the derivation of the conditions for both the particular common root values. Let's solve few questions.